Alright, hello. Today what we're going to be doing is starting a new knowledge base to get into the study of curvy lines. We have finished everything to do with straight lines. Y equals mx plus b, slope, and y-intercept, and all these writing equations. We just finished systems of equations. Everything was about straight lines. Now what we're going to do is get into curvy lines, but we need to get some building blocks for that. And we're going to start with simplifying monomial expressions. Monomial meaning one term. So all these expressions that have to do with only one term of math, one piece of math, which means we're going to deal only with multiplication. So we're going to see a lot of, that could be confusing rules, but keeping in mind that everything is revolving around multiplication. With adding and subtracting, you can only add and subtract two numbers if they have the same variable to the same exponent. With multiplying, you can multiply anything you want, so there are some rules around that though. So we're getting into something that's called the Laws of Exponents, which basically tell you about all of the rules around multiplying numbers together. Okay, so we're dealing with all the laws of exponents. The first law that we're going to talk about is zero exponent and negative exponents. But before we get there, we're going to dig into our prior knowledge of how exponents work. Okay, so all of the prior knowledge for exponents that we need to know what the meaning of exponents are. What is the meaning of this tiny little number raised on top of another number that we call the base? So this number is called the base. This number is called the exponent or power. And so what does that little number mean we do at the base? It just means we multiply the base by itself that many times. So this just means we're taking 3, multiplying it by itself 4 times. So we have 3 times 3 times 3 times 3, which is 81. So that's the meaning of exponents. We also need to remember the importance of parentheses. We've done this in the past for this year. So how important are parentheses when it comes to exponents? So in this example, we have negative 3 inside parentheses, and it is the negative 3 that's being raised to the 4th power. So we say this negative 3 to the 4th power. And what does that mean? That means we're multiplying that negative 3 by itself 4 times. So since the negative is inside the parentheses, it's part of what's being multiplied by itself. So when we multiply that out, it looks like negative 3 times negative 3 times negative 3 times negative 3. And then we have to remember how negatives work when it comes to multiplication. A negative times a negative is a positive. So when we multiply this negative times this negative, it becomes a positive. When we multiply this positive times this negative, that becomes a negative. And then when we multiply that negative times the last negative, negative times negative is positive. So the answer comes out to be a positive number. Negative times negative is positive, negative, positive again. Okay, so it comes out to be a positive number. So we get positive 81. But again, we're remembering the power of parentheses. So I had that previous example where the negative was inside the parentheses. But what about this example if the negative is not in parentheses? Okay, so we're going to compare this with this so that we can understand the importance of parentheses. In this second example, that negative is not inside the parentheses, so that negative is not being raised to the 4th power. Only the 3 is being raised to the 4th power. So again, going back to prior knowledge, we have to remember that since there are no parentheses, the negative is not being multiplied by itself 4 times. Okay, only the 3 is being raised to the 4th power. So when we multiply this out, we have the negative that's all the way out to the side. The negative is all the way out to the front. That's not being raised to the 4th power. Only the 3 is being multiplied by itself 4 times. So we have to remember the power of parentheses. This expression would of course be negative 81. So that's all the pieces of knowledge that we have to recall from earlier this year to bring into the new information. So we're going to get into new information. And we're going to start with something that we're calling the Laws of Exponents. And there are a few laws of exponents that deal with what are all the rules when it comes to multiplying anything you want. Remember, you can only add or subtract like terms, but you can multiply anything you want as long as you follow certain rules. And those are the laws. So the first law of exponents we'll deal with is called the law of the zero exponent. What this basically says is any number raised to the 0 power equals 1. And so I have that even written out. Anything raised to the 0 power equals 1. That's the first law of exponents we're going to deal with. And so what we'll do is see a few examples of that law in action. So if we start with our first example, and we begin with a simple expression, 3 to the 0 power, we have to remember what the law states. The law states anything to the 0 power is 1. Therefore, 3 to the 0 power is 1. So we have to know that law. Anything to the 0 power is 1. Here's another example. So let's say I have another example. What if it's not a number to the power? What if I had a variable to the 0 power? So what if I gave you a variable being raised to the 0 power? It doesn't matter. The law still states anything to the 0 power is equal to 1. So even in this case, because we have x to the 0 power, it's still equal to 1. So when we simplify that expression, we get 1. If I raise a table to 0 power, I get 1. If I raise a cow to 0 power, I get 1. So now let's get into something that looks a little bit more complicated, but we have to remember the power of parentheses. So let's do another example. Let's say I have this crazy looking thing, but it's inside parentheses being raised to the 0 power. That means that this whole thing, no matter what is inside, this whole thing is being raised to the 0 power. And the law states anything to the 0 power is 1. So even though this looks complicated, the whole thing is being raised to the 0 power, so the whole thing is 1. So the law is still applying to this expression, even though it looks a little bit more complicated. It's still equal to 1. So isn't that such an easy law? So now let's get into something that might be a bit tricky. So let's look at a different example. So let's look at a different example. We have this expression. Let's simplify this expression. Now, you may think, well, we just did that. Well, no, we didn't just do this, because in the previous example, we had parentheses around it. In this example, we're remembering the power of parentheses. What exactly is being raised to the 0 power? Is the x being raised to the 0 power? No, only the y is being raised to the 0 power. So what this example is showing is to recall what is happening between the terms. So let's recall what is happening between these two terms. What's going on right there is multiplication. So we have to remember that what's happening between those two terms is multiplication. So we recall that between the x and the y to the 0 power is multiplying. So can we simplify x? No, it's just x. Can we simplify y to the 0 power? Of course we can. That is the law. So the law will only apply to the y to the 0 power. The x remains x. The y to the 0 power is what we're applying the law to, so that becomes 1. Okay, so we're multiplying x times 1. X times 1, because the law states that anything to the 0 power is 1. And x times 1, of course, is x. So when we simplify this expression turns out to only be x, because this is x times 1, x. All right, so we see how this law can look when it comes to getting a little bit confusing. So let's see if I can stump you with another example. I'm going to write a crazy looking example. We're going to start with this. Let's say I have that crazy looking expression, but I raise it to the 0 power. So here's another example. So let's simplify that mess. Okay, you're looking at this craziness, you might feel a little bit of anxiety, but recall, everything in here is inside parentheses. Everything in here is inside parentheses, and it's being raised to the 0 power. So just remember the law. The law states anything raised to the 0 power is 1. So this whole thing being raised to the 0 power is 1. Trust the law. When we simplify that expression, it turns out to be 1. There's that. All right. So now what we're going to do is get into a more confusing law, I think. So that was the law of the 0 exponent. Now let's look at the law about the negative exponent. What happens if we have an exponent that's negative? So the law states that if you have a term with a negative exponent, see, the exponent is what's negative. It doesn't mean the number is negative. It simply means we flip that term from, in this case, the top to the bottom, and then the power becomes positive. The exponent becomes positive. So if we have a negative exponent, all that's happening is we're bringing that number down, and then the exponent becomes positive. So a negative exponent on top moves the term to the bottom and makes the exponent positive. Okay, a negative exponent on top. This is on top of a fraction, right? This is on top of 1. A negative exponent on top moves the term down and makes the exponent positive. It does not make the term negative. Okay, it doesn't mean that this is a negative a. It means it's a positive a, it's just on the bottom of the fraction. On the same law, if you have a term that's already on the bottom, if you have a term that's on the bottom with a negative exponent, that means the term moves to the top and the exponent becomes positive. Okay, so if we have a negative exponent on the bottom of an expression, all that means is that the term moves to the top and it makes the exponent positive. Once again, it does not make the term negative. This negative in the exponent does not make this negative. It doesn't change the sign out here. It does not affect that. Okay, just moves it to the top and becomes positive, or moves it to the bottom and becomes positive. So let's see that law in action. If I have an expression that starts pretty simply, would say, if we have an expression that starts kind of simply, 3 to the negative 2 power. I'm going to start with a simple expression. How do we simplify this monomial expression? We recall the law that we just used. In this case, the law states that anything to the negative power means we're going to move that term to the bottom of a fraction and make the power positive. We're going to move that term to the bottom of an expression and make that power positive. So if I have 3 to the negative 2 power, I'm going to move that term to the bottom of an expression and make the power positive. Okay, so if I have 3 to the negative 2 power, I'm just moving it to the bottom of a fraction and making the exponent positive. So it doesn't make the number negative, it makes it really, really small. That's what a negative exponent does, it makes it really small. all we need to do now is evaluate that expression. So if we have 1 over 3 squared, that's 1 over 3 times 3, which is 9. So when we're looking at 3 to the negative 2 power, it doesn't make it a negative number. It's still a positive number. It's just a positive small number. Okay, so 3 to the negative 2 power is still positive, but 1 over 9. Okay, it's just a small number, really close to 0. So that's how the law of negative exponents works. Let's do a few more examples. So here's another example. Let's say I had the term xy to the negative 2. So again, with parentheses, we have to ask, what is happening with that negative 2 exponent? What is being raised to the negative 2 power? Only the y is being raised to the negative 2 power, not the whole thing. The x is not being raised to negative 2 power. So what we're looking at is x times y to the negative 2 power. That's what we're looking at. And so from there we can apply the law. And the law states, anything raised to the negative power keeps it positive, we just move it to the bottom and make the power positive. Okay? So it doesn't change the sign, it moves it down to the bottom. So what we have here is then x times 1 over y to the positive 2. So this is what we end up with. But we can still simplify that. Remember when we're multiplying fractions, top times top. Okay, so we keep that x at the top over y to the second power. So this is how we use that law of negative exponents. Okay, so we have the x times 1 at the top over y squared stays at the bottom. That's how negative exponents works. But we can look at this example another way. So I'm going to rewrite this example. I want you to look at it another way. Since we're talking about, with the law of negative exponents, terms on top or terms on the bottom, what we can do is look at negative exponents in the term of, is it staying or is it moving? Is it staying where it's at or is it moving to the bottom? So let's see this another way. The x is going to stay because it does not have a negative exponent. The y is going to move because it has a negative exponent. So since y has a negative exponent, that term is what's going to move. The x stays put, has a positive exponent, it's going to stay put. So that means we are talking about an xy squared over something, right? Over 1, technically. But since the x stays and the y moves, the x stays on top, it's the y that moves to the bottom and becomes positive. Okay, so that's how we can look at it. It's that negative exponent to the y that's going to move it to the bottom and make that exponent positive. So either way, we're looking at x over y squared, which is what we did over here, okay, when we applied the law. So I just want you to think, an easier way for me anyway, to think in terms of staying or in terms of moving. Let's do some more examples so it can become a little bit easier, hopefully. So look at this crazy looking example. And I'm gonna keep thinking in terms of staying and moving. So if we have this expression, and I want you to simplify it, again, let's think in terms of staying and moving. We're talking about the law of negative exponents. So we're thinking about staying and moving. The 7 doesn't have a negative exponent, it stays. So this stays, the a stays. The b has a negative exponent, it's going to move to the bottom. The 3 is going to stay at the bottom, and the w is going to stay at the bottom. So the only thing that's moving is that term with a b. So this stays, this is going to move, this stays, and this stays. So the 7 stays, the a stays, the b is no longer there. The 3 stays, the w stays, but then the b is what's going to come down and then have a positive exponent of 2. So that's what's going to happen. Okay, so that's the law of negative exponents being used. And once again, I'll write that law down, keep it fresh in our heads. Anything to the negative power moves it to the bottom and the power becomes positive. That's just what's happened. So the only thing that we're going to switch about this bottom is a little bit of algebra etiquette. And algebra etiquette states that when you have multiple variables being multiplied together, just list them alphabetically. And since b comes before w alphabetically, we're going to move that whole term with its exponent as well. We're going to move it to in front of the w. So b squared times w. And just when we're talking about algebra etiquette, that's how it's supposed to look. All right, so that's the law of negative exponents at work. Let's see another example with a lot of craziness going on with the law of exponents at work. And there is going to be a few, at least, questions on the state exam that have negative exponents. So the more we get familiar with it, the better. All right, so again, we're going to think in terms of what stays and what moves. Since the 2 has a negative exponent, this is going to move to the bottom. Since this term x has a positive exponent, it's going to stay right there. It's not going to move. The z to the negative exponent is going to move to the bottom. Now let's look at the bottom. We have a y to the negative 4. Since that's negative, this is going to move to the top. So we're using both laws dealing with negative exponents. Okay, so the first law of negative exponents says if you start at the top, it moves to the bottom and becomes positive. If you start at the bottom with a negative exponent, it moves to the top and becomes positive. So we're going to use that same law with this example. All right, so when we rewrite it, we're going to think, all right, the 2 stays. I'm not going to write it at the top. The x squared stays. So the x squared stays. Then I have my line. The 2 to the 3rd power comes down. The z to the 7th power comes down. And that y to the negative 4th is no longer at the bottom. It's going to move to the top and become positive. So there's our expression. All of the moving happened using the law of exponents. Okay, so the 2 moved down, the y moved up, and the z moved down. So all we do now is simplify this mess. Okay, so at the top we had x squared y to the 4th. At the bottom we have 2 to the 3rd power, which we can evaluate that. So don't leave it 2 to the 3rd power, evaluate it. 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8. And then z to the 7th power stays there. And there's our simplified expression. So again, we wanted to take this craziness with all these negative exponents, apply the laws of exponents, and we end up with this. Okay, so it's just a matter of applying those laws of exponents. Let's do another example. I like to keep the examples coming so you can see how much fun or easy this is, which I think is kind of fun. So let's do this one more example. Throw some other laws of exponents in there. So here's this example. We have a lot of craziness going on, and we can see some laws of exponents at work. We want to think what is moving, what is staying. So let's think all the laws of exponents that we're using. We're using the law of negative exponents at the top. They move to the bottom and become positive. We think of the law of exponents that start at the bottom when they're negative. They move to the top and the exponents become positive. And we think of the law of the zero exponent because we're going to apply that here. Remember, any number to the 0 power becomes 1. Okay, so let's see what's going to happen with this. The 7 is going to stay put. The a to the 4th is going to stay put. The b to the negative 3, that's a negative exponent, so it's going to move to the bottom and become positive. C to the 0 is going to become 1. The 5 stays at the bottom. And the d to the negative 2 moves to the top and becomes positive. So all these things are happening at the same time. The 7 stays. The a stays. The b will move. The c turns to 1, so it's going to, multiplying 1 doesn't change anything. the d to the second power on the bottom is going to move up to the top. And then that negative 2 turns into a positive 2. At the bottom, the 5 stays. The d already moved to the top. The b from the top is going to come down to the bottom. And the c to the 0 power turns into 1. 1 times anything is that number, so it doesn't affect anything. This is our simplified expression, because we use all those laws of exponents. All right, so we applied all of these laws to this example, and we have that simplified term. So that's it for today as far as laws of exponents. We're going to learn many more laws, but we're going to get some practice done from the textbook with these, and then we'll come back for more, because simplifying monomials is pretty important. So we'll stop there, and then we'll pick up with more laws.